Now we are considering module 4, that is electric and magnetic fields in materials. Before going to the in-depth of our syllabus, we consider our portions which we studied in the schools. Mainly, as this is dealing with materials, the main types are conductors, dielectrics and insulators. Here we are first considering conductor. So what is a conductor? We know conductor conducts. As we are considering the electric field and magnetic field, the conductor conducts electricity. So what is the difference or specialty of conductor? The outer electrons of the atom are easily detachable and migrate with application of even a very weak electric field. This helps a lot in conducting. But while moving, the moving electrons strike to the adjacent atoms and rebound in random direction. And this drifting is known as drifting of electrons. And this happens along with the formation of a velocity, and that is known as drift velocity Vd. Now current constituted due to drifting in metallic conductors is called drift current, and drift velocity is also a vector. So vector Vd is proportional to vector E. What is vector E? That is already known. Vector E is electric field, and Vd is proportional to E. To make the proportionality sign to equal, Vd is equal to minus mu E E. And what is minus mu E? It is a constant. And why negative? It represents that the velocity of electrons is against the direction of field vector E. Now what are the properties of a conductor? Conductor we can say all in as they conduct, but they have some more properties. Under static condition, no charge and no electric field can exist at any point within the conducting material. Next property is charge can exist on surface of conductor, giving rise to surface charge density. Within a conductor, charge density is always zero. Charge distribution on surface depends on shape of surface, and the conductor surface is an equipotential surface. Conductor surface have that equipotential, means the charge is distributed almost equally. Now what is dielectric? Dielectric, this term is more deal with the capacitors. Mostly in case of capacitors, we have seen the dielectric. Between the capacitor plates, dielectric is kept, and the difference between dielectric and capacitor is that at ordinary field, the electrons cannot be moved from the nucleus. That is the difference between dielectric and conductor. In case of conductor, they will move with a very weak field. So electrons are rigidly bound to their nucleus, so that ordinary field will not be able to detach them. This is dielectric. And if electric field is applied, this will twist and strain molecules to orient positive charges in the direction of field and negative charges oppositely. And this is known as polarization. This condition is polarization. And in case of dielectric materials, there are two classes. One is polarized and other is non-polarized. In case of polarized, with the help of application of electric field, it will shift the positive and negative charges slightly within the molecules to give rise to a dipole. Now what is a dipole? It is two charges separated by distance, positive charge, opposite charges, positive and negative. So in uncharged condition, positive and negative charges are so close to each other that their action is neutralized. Molecules form dipoles even in absence of an electric field. Such dielectrics are called polar dielectric. Example is water and ammonia. Resultant electric field of a polar dielectric is zero. On the application of a field, dipoles are rearranged themselves so that their axes are in alignment with the applied force. This shift results in instantaneous current, and that is called displacement current, and this occurs or this causes in very small fraction of second. Now as we see the properties of conductors, there are properties of dielectric materials. Dielectric does not contain any free charges but contain bound charges which are under internal molecular and atomic forces and cannot contribute to conduction. As said earlier, these are the diagrams which represents unpolarized atom of dielectric and polarized atom. The left side is an unpolarized atom of dielectric. You can see the nucleus, positively charged nucleus at the center, negatively charged electron cloud surrounding it in unpolarized, and polarized nucleus is there, and the electrons are also around. This is polarized condition. Now as mentioned earlier, electric dipole means two equivalent opposite charges separated by distance. Here we considered minus q plus q, and the distance is small d, that we studied earlier. Now mathematical expression for polarization, relationship between electric flux density and dielectric constant. When dipole is formed due to polarization, there exists an electric dipole moment denoted as small p, that is also a vector. And for vector p, that is equal to q vector d. What is q? Magnitude of one of two charges. What is vector d? Distance from vector from negative to positive charge. And consider small n is number of dipoles per unit volume, delta V is total volume of dielectric, capital N is number of dipoles, then capital N is equal to small n del V. The total dipole moment obtained using superposition principle is vector P total is equal to q1 vector d1 plus q2 vector d2 plus etc. If the number is up to n, that is sigma is equal to 1 to n del V. What is n del V? That is the total number of dipoles, qi di. If poles are randomly oriented, vector P total is 0, but if dipoles are aligned in direction of applied vector E, then vector P total has a significant value. Thus polarization vector P is defined as the total dipole moment per volume. That is, vector P is equal to limit del V equal to 0, sigma is equal to 1 to n delta V, qi di by delta V. And this unit is measured in coulomb per second square per square meter. Now the units of polarization is same as that of flux density vector d. Now what is vector d? Vector d is epsilon vector E plus vector P. Consider this as first equation. For isotropic and linear medium, vector P and vector E are parallel to each other at every point and related to each other, as vector P is equal to psi E epsilon naught vector E. Let this be equation 2, where psi E is dimensionless quantity called electric susceptibility of the material. We know what is susceptibility is. Now substituting this equation 2 in 1, we'll get, instead of P you are substituting equation 2, so you get vector D is equal to epsilon vector E plus psi E epsilon naught E. That is, taking epsilon naught and E outside, vector E outside, vector D is equal to psi E plus 1 epsilon naught vector E. Therefore vector D is equal to epsilon R epsilon naught vector E. What is epsilon R? It is equal to psi E plus 1. Therefore, what is epsilon R and epsilon naught? It is commonly known as epsilon. What is epsilon? It is permittivity of dielectric. Therefore, vector D is equal to epsilon vector E. This is also studied earlier in the previous module. And psi E plus 1 is called relative permeability epsilon r, or dielectric constant of dielectric material. Now we have a problem. Find the magnitude of vector D and vector P for a dielectric material in which mode vector E is equal to 0.15 millivolt per meter, psi E is equal to 4.25. Now what is vector D? Vector D is equal to, epsilon naught epsilon r vector E. Epsilon r is equal to, that is also known, psi E plus 1. Psi value is given 4.25 plus 1, that is 5.25. What is mode D? Mode D is equal to, what is mode D? 8.854 into 10 raised to minus 12. What is that? That is epsilon naught into 5.25, that is epsilon r, into 0.15 into 10 raised to minus 3, that is mode E. So you will get 6.9725 into 10 raised to minus 15 coulomb per meter square. And what is vector P? That is polarization, that is psi E epsilon naught vector E, that is equal to 4.25 into 8.854 into 10 raised to minus 12 into 0.15 into 10 raised to minus 3, and that is known as 5.644 into 10 raised to minus 15 coulomb per meter square. And what is this? This is known as the dipole moment. So what is vector P? That is dipole moment. Thank you.